In summary, Brahe did. First, he discovered the nova stella. Second, he discovered that if it's not due to Earth's atmosphere, there are no parallax. Third, he discovered that the stars are not eternal. Fourth, he discovered the accurate astronomical data for his time. Fifth, he discovered about stellar and planetary precession. Sixth, he discovered about of a better measure of Earth's axial tilt. Seventh, he discovered about anomalies in pho- photo- Ptolemaic model surface. 8. He provided that comets are found in the celestial domain. 9. He removed the necessity of crystalline celestial spheres. Tycho Brahe and Johannes Kepler give to us a better understanding of planetary motion through their collaboration efforts. Tycho Brahe's observational groundwork and Johannes Kepler's mathematical formulation of the three laws of planetary motion marks a significant shift in astronomical understanding, leading to the rejection of outdated models and the establishment of a new paradigm based on empirical data and mathematical rigor. Their collaborative efforts exemplify the iterative nature of scientific progress and the importance of advancing our knowledge of the universe. Kepler's persistence, philosophical considerations, and reliance of Brahe's observations were crucial in the development of his three laws of planetary motion. Through his meticulous analysis and innovative thinking, Kepler laid the foundation of a new understanding of planetary motion that revolutionized astronomy and paved the way for further scientific exploration. Tycho Brahe's belief in a geocentric model of the universe, where the Sun orbits the Earth while the other planets revolve around the Sun, shaped his astronomical observations. Brahe meticulously recorded extensive astronomical data in support of his model. Johannes Kepler, who later utilized Brahe's records, employed them to validate the heliocentric model and derive the orbit laws. By combining Brahe's measurements with his own geometric analysis of the Sun and Mars positions, Kepler observed that planets accelerate when nearer to the Sun. This observation led him to groundbreaking realization that Mars followed an elliptical orbit, challenging the prevailing notion of circular planetary paths. Kepler's discoveries, facilitated by Brahe's data, revolutionized our understanding of planetary motion and laid the groundwork for modern astronomy. This law marked a significant departure from the prevailing belief in perfectly circular planetary orbits. Kepler's insights into elliptical orbit challenged the traditional view of circular paths and introduced the concept of ellipse as the new perfect shape for planetary trajectories. He emphasized that a circular orbit is a special case of an ellipse, where the foes merge at the center of the circle. By introducing the elliptical model, Kepler revolutionized our understanding of planetary motion and paved the way for a more accurate description of celestial dynamics. This states that the line connecting a planet to the Sun, known as the radius vector, sweeps out equal areas in equal time interval as the planet moves along its orbit. This law signifies that a planet moves faster when closer to the Sun and slower when farther away. ensuring that the area swiped out by the radius vector remains constant over time. The concept of equal areas replaced the notion of uniform speed in traditional models, emphasizing the uniform rate at which the radius vector covers area as the planet orbits to the Sun. Kepler's law of equal areas highlights the dynamic nature of planetary motion and the relationship between a planet's speed and its position in its orbit. The law of periods states that the square of a planet's orbital period, the time for one complete orbit, is proportional to the cube of its average distance from the Sun. This law reveals the harmonious relationship in the universe, suggesting a certain order and symmetry in the planetary motions. Kepler's exploration of his law led to philosophical reflections on concepts like the harmony of the world and the idea of a prime mover, akin to Aristotle's notion. Kepler's musings extended to the concept of anima motric or the motor life, hinting at early notions of gravitational force exerted by the sun to maintain the planets in their orbits. The law of periods, also known as the harmonic law, underscores the interconnectedness and balance in the celestial realm, reflecting Kepler's profound insights into the cosmic order and the underlying principles governing planetary motion.